We're going to talk about sequences, and the first thing we need to do with our sequences is identify if it's a sequence or not. So we're going to look at a couple of examples. Let me see if I can. Just going to look at one at a time, and we're going to see if they are sequences. So our sequences that we're going to talk about are these. We've got these numbers, 1, 5, 9, and 13. And are they increasing or decreasing by the same value between the numbers? If so, then yes, they are sequences. And if not, then no, they're not sequences. So let's look. We've got 1 to 5. To get to 5 from 1, I have to add 4. To get to 5 to 9, we add 4. And to get to 9 to 13, we add 4. Now, since we're adding 4 each time, yes, this is a sequence. Okay, so let's look at the second one. To get from 1 to 3, we add 2. To get to 3 to 5, we add 2. To get to 5 to 8, though, we add 3. Since all these numbers are different, then no, this is not a sequence. Let's look at another one. We've got 5 to 10, we add 5, 10 to 20, we add 10, 20 to 40, we add 20. I know they're going up in a certain way, but because they're not all the same number, no sequence here. So then let's look at this. So these we were adding and adding and adding. We could also be subtracting. So to get from -5 to -8, we would subtract 3. To get from -8 to -11, we would subtract 3. To get from -11 to -14, we would subtract 3. All those are the same, subtracting 3, so they are, this is a sequence. So if we know that they are a sequence, then we can take that sequence and we can continue it. So we've got 9 to 13, we would add 4. 13 to 17, we add 4, so 21 plus 4 is 25, plus 4 is 29, plus 4 is 33. Oh my gosh. Alright. To get from 5 to 2, we would subtract 3. From 2 to -1, subtract 3. Subtract 3, so -4 minus 3 is -7, minus 3 is -10, minus 3 is -13. -8 to -2, we would add 6, add 6, add 6, so 10 plus 6 is 16, plus 6 is 22, plus 6 is 28. So we find the pattern, adding or subtracting, and then we just find the next. So these are arithmetic sequences, and that's just a sequence in which the difference between any two consecutive terms, consecutive means next to each other, is constant. And constant means that it's the same. So the difference is going to be the same between all of them. So you can see all these are plus 4, all these are minus 3, all these are plus 6. So we call that difference the common difference. So this is the numerical difference between any two consecutive terms in our sequence. I apologize for this docking my camera. Okay, so we can write these as a function and evaluate our function for any number. So the formula for our function is going to be f of n equals d n minus 1 plus a1. So let's define those terms. So f of n, remember this is like our y, our n here, and our n here. This is going to be like our x. So this is going to be our nth term, or like our x value. The d is going to be our common difference. And this a1 out here is going to be the first term that we are given. First term that we are given. Okay, so let's look at this. So we have this example up at the top. Same thing. We said that to get from here to here, we added 4 each time, right? So then we filled in 25, 29, 33. So we can write our formula here for this. Our D is that positive 4. The A1, that first term we're given, is 9. So we write this, f of n equals 4 n minus 1 plus 9. Now if I'm asked, like, let's find the 17th term, then I want to find f of 17. So I'm going to plug this into my calculator, and I'm going to do it in the graphs like we learned how to use. And I'm just going to, where I see n, for calculating purposes, or the calculating purposes, I'm going to put it as an x. Sorry, lost my train of thought. Because our calculator can only do f of x. So I've got my graph pulled up already. Everything's cleared, so I'm going to type it in exactly like we wrote it. For open parentheses x minus 1, close parentheses plus 9. Graph that. And remember, I can find that f of 17 by going menu 5, 1, and then typing in 17, enter my f of 17 equals 73. So in this sequence, the 17th term, so this is 1, 2, 3, 4, 5, 6, 7, so the 17th one is 73. And I didn't have to do anything, I didn't have to keep adding. Okay, so let's do the same thing here. We got 7 to 13, that's plus 6. 13 to 19 plus 6 plus 6. So that means that our D is positive 6. Our A1 is the 7. It's given to us. So f of n equals 6 n minus 1 plus 7. So this tells us, let's find the 19th term. So I want to know, what is f of 19? Again, going to my calculator. I'll walk through this step. Go into new document, no, add graph, 6, open parentheses, x minus 1, close parentheses, plus 7. There's my line, menu 5, 1, and 19. 115. All right. Negative 11, negative 11 to negative 8, that's 8. We would add 3. So my D is positive 3, A1 is negative 11. So let's write our equation. F of n equals 3 n minus 1 plus negative 11. Going to my graph because it wants to know what? we want to know f of 21. We want to know that 21st term. So, new document, don't save, add graph, type it in, 3, open parentheses, x minus 1, plus negative 11. Menu 5, 21, enter, and that is 49. Alright, final one, from negative 2 to 0, we add 2. So my z equals 2, a1 equals negative 2, write our equation. F of n equals 2, n minus 1 plus minus negative 2. We want to find f of 201. Let's see, new document, don't save, add graph, 2, open parentheses, x minus 1 plus negative 2. The 200th term is 201st. Is 390. Oh, my pen is dying. 390.